Let's be looking at this rectangle ABCD, and let's solve 1, 2, and 3 here, okay? So in number 1, notice what's given to us, okay? We're starting out by knowing that BAP, the measure of that angle, is 25 degrees, okay? But let's apply what we know about rectangles. We know that we've got 4 90-degree angles here. We know the opposite sides are going to be congruent. And we know that the diagonals bisect each other. That's a new one. The diagonals bisect each other but are also congruent. So I'm going to give those all just 2 tick marks because each part is going to be the same there, okay? So in number 1, we are trying to find the measure of angle APB. So we want to be able to identify what that angle is. That angle is right here. APB is talking about that angle there. So there's a couple different ways we can solve this, but what I see and what I want you to see as well is that that is an isosceles triangle here. Triangle APB is an isosceles triangle because 2 of the sides are congruent. So this angle that was given to us, angle PAB, that was 25 degrees, which means this other base angle is also going to be 25 degrees. So angle APB is going to be 180 minus both of those base angles. So 130 degrees. So that angle right there is going to be 130 degrees. The next angle it's asking us to find is measure of angle PCB. PCB, which is right here. Okay? Now, notice, there's, again, a couple different ways. We could do a linear pair with that 130 and say that this top angle is 50. Then we could say 180 minus 50 is 130. And we got to cut that in half, and both of these will be 65 because of the isosceles triangle. So that's one way we could do it. Another way is saying, okay, up here at angle A, that's 25 degrees. So the other part needs to be 65 degrees. And then what's the relationship between that 65 and PCB, the angle we're trying to find? Alternate interior angles. So you've got a couple different ways to tackle these. You can use that previous knowledge from parallel lines cut by a transversal, or you can look for triangles to implement the triangle sum theorem, okay? So the last one is saying, okay, AB is Y, BC is 5 minus X, CD is negative 2X plus 4, and then AD is 2Y, okay? So what I would do here is I see opposite sides. I know opposite sides are going to be congruent to each other. So I'm just going to set opposite sides equal to each other down here in number 3. So I've got y equals negative 2x plus 4. And then 2y equals 5 minus x. Both of these equations involve an x and a y. So I'm going to use a system here. So you could rearrange it and do elimination if you wanted to. Okay, like I could make this 2x plus y equals 4, and this bottom one, x plus 2y equals 5. Okay, I could solve that by elimination then, okay? Or from my original, I could substitute this value, negative 2x plus 4 equals plain old y. So I'm going to substitute that in for y right there. Okay, so it's going to be 2 times my substitution, negative 2x plus 4, equals 5 minus x. So as I solve this, it's going to be negative 4x plus 8 equals 5 minus x. So then that's going to be 3x equals 3, so x equals 1. And if I plug that back in, y equals negative 2 times 1 plus 4. That means y will equal 2. So here we've got what our x and our y are. So I'm going to plug that in then. I'm going to plug that in. And I'm going to see that both of these sides are 4. AD, BC are both going to be 4. And top and bottom are both going to be 2. Again, trust the math. Don't just trust the diagram. Okay? What was it originally asking us for, though? It was asking us for PD. PD here. Okay? So, how could I find that? Well, I could figure out what the entire diagonal is, right? Because the entire diagonal is part of this right triangle here, okay? So I've got a right triangle with side lengths 2 and 4, and this represents the entire diagonal. So I'm going to call that, we've already used an x, I'll call it c. So 2 squared plus 4 squared equals c squared. All right, so c squared is equal to the square root of 20. All right, now I'm going to use this square over here. Square root of 20 breaks down into square root of 4 times square root of 5. Square root of 4 is a nice number. So square root of 4 breaks down to 2. 2 gets to come outside. And then that is going to be square root of 5 left over underneath the radical. Now, that represents the entire diagonal, but I don't want the entire diagonal, okay? I want half of it, so PD is going to be 2 square roots of 5 divided by 2. We want half of it, so we're going to divide it in 2. So PD is going to equal the square root of 5 units, which is approximately 2.236 units, okay? So, real tough one there at the end with the system, plugging back in, Pythagorean theorem, cutting the diagonal in half. There's a lot going on there, but you're using the properties in order to set up the problem, okay? Pay attention to the next video when we look at the square problems.